All right, let's talk about AI. Not the sci-fi robot takeover kind of AI, but the AI that's already woven into our daily lives. You hear the buzzwords all the time, right? Well, today we're going to decode them. We're going to learn how to speak the language of machines.
I mean, think about it. It's in the shows Netflix recommends, the music Spotify picks for you, even the directions your phone gives you. AI is absolutely everywhere. But the words it uses, machine learning, neural networks, algorithms, can feel like a completely different language. So let's fix that. This is your personal guide to speaking AI. So, to get our bearings, let's start with a map of the AI universe. All these key terms, they're not separate things, they actually fit together. The best way to picture it is like a set of Russian nesting dolls, where each concept fits right inside the next.
Okay, so first up, we have the biggest doll on the outside, artificial intelligence itself. This is the whole big idea, the entire field. It's the grand ambition of making machines smart enough to do things that typically require human brains, like learning, reasoning, or solving problems.
Now, let's open that first doll. Inside, we find machine learning, or ML. And this is where things get really interesting. See, instead of programming a computer with a million rigid rules for every single situation, we do something different. We just give it a ton of data and let it figure out the patterns on its own. It learns. And if we go one level deeper, we get to the smallest, most powerful doll, deep learning. This is a very specific, very powerful type of machine learning. It uses something called neural networks, which are basically layers of digital nodes that process information in a way that's loosely inspired by our own brains. This layered approach, it's the engine behind almost all the mind-blowing stuff you see today, from generating realistic images to translating languages on the fly.
Okay, so we've got the layers down, but how do you actually, make an AI? Well, I've found the best way to think about it is like baking a cake. Seriously, you just need the right ingredients and a good recipe. Your first and, without a doubt, most important ingredient is data. This is your flour, your sugar, your eggs. It can be anything: text, images, boring spreadsheets, you name it. And just like with a cake, the quality of your ingredients is everything. Good data, good AI. It's that simple. The second key ingredient is the algorithm. And if data is the flour and sugar, the algorithm is your recipe card. It's the set of step-by-step instructions that tells the system exactly what to do with all that data to get the job done, whether that's finding a cat in a photo or predicting tomorrow's weather. And this is how it all comes together. This is the baking process. You take your ingredients, the data, and the algorithm, and you start training. The system just churns through the data again and again and again, following that recipe, tweaking and learning until it becomes a powerful finished tool. And the final result of all that baking? You get the model. This is your finished cake. It's the fully trained, ready-to-use system that can now look at brand new, totally unseen data and make a smart prediction or decision based on everything it's learned. But as it turns out, there isn't just one way to train a model. Just like people have different ways of learning, so do machines. Let's take a quick look at the three main teaching styles for AI. So you've got three main flavors. First, there's supervised learning. This is like studying with flashcards. You give the AI a bunch of examples with the right answers already labeled, like thousands of emails marked spam or not spam. Then there's unsupervised learning. Here, you just dump a pile of data on the AI and say, find something interesting. It's great for discovering hidden patterns, like how a store might group its customers. And finally, you have reinforcement learning. This is learning by trial and error. The AI gets rewards for good moves and penalties for bad ones. It's exactly how an AI learns to master a complex game, like chess or Go. All right, now that we've got the lingo down, let's talk about where this stuff actually pops up in the real world. And more importantly, why any of this matters to you. Have you ever used a chatbot to ask a question or a translation app on vacation? Then you've used natural language processing, or NLP. It's the whole branch of AI that's all about teaching machines to understand us, to understand human language. It's how your phone gets it when you say, hey, set a timer for 10 minutes. And what about when a machine understands a picture? Well, that's called computer vision. This technology basically gives machines a pair of eyes, letting them see and interpret the visual world. It's the magic behind unlocking your phone with your face, or, on a more serious note, how a doctor can use AI to spot tiny anomalies in an MRI scan. So these tools are unbelievably powerful. And you know what they say? With great power comes some really important things to think about. It's not just about what this technology can do, but how it actually behaves out in the wild.
This brings us to two really crucial ideas. The first is bias. You can think of this as a technical problem. If the data you feed an AI is skewed or incomplete, well, its answers will be skewed and incomplete too. It's that classic saying, garbage in, garbage out. Then you have the much bigger picture, AI ethics. This is the whole field dedicated to figuring out how we build and use these systems responsibly, making sure they're fair, transparent, and actually helping society.
Okay, finally, let's clear up one of the single biggest misconceptions about AI. We have to draw a very clear line between the AI we have today and the AI you see in the movies. They are not the same thing. Let's be super clear here. Everything we have talked about today, every single app, every single system, is what we call artificial narrow intelligence, or ANI. It can be brilliant, even superhuman, at one specific task, like playing chess, but that's it. It can't do anything else. Artificial general intelligence, or AGI, that's the idea of a machine with the flexible, creative intelligence of a human. That is still completely theoretical. It's science fiction. It does not exist. So there you have it. You've got the vocabulary, you can be part of the conversation because the language of machines is no longer a mystery. And that brings us to the most important question of all. Now that we can speak its language, what are we going to demand from the AI that we build?